It's a Friday afternoon. You're sitting at home in your office, getting ready to wrap things up for the weekend, when suddenly you get a message on Slack from your boss. Never fun, right? Well, it turns out she has a new project for you. It has come to management's attention that we need to shard our database. And guess what, buddy? You're in charge. And you have 1 week to come up with a sharding strategy. What would you do? Where would you even start? Don't worry, I got you. In this video and some follow-up videos, I'm going to cover what you should consider when you start to think about sharding your database. So for this first video, I'm going to cover some of the different types of sharding. In the second half of the video, I'm actually going to bring in somebody from PlanetScale's solutions engineering team, and he's kind of going to walk you through some of the things he sees in practice here when sharding databases. I will be making some more videos on sharding, so if you have any questions or requests about sharding, please leave them in the comments below. All right, let's get started. So when it comes to sharding, there are essentially 3 different types: lookup-based sharding, range-based sharding, and hash-based sharding. Let's start with lookup-based sharding first. So lookup-based sharding, also known as directory sharding, is essentially when you map your data to specific shards using something we call a lookup table. All right, so let's look at an example here. Let's say we have this members table that has ID, court, and the name of the member. And maybe we want to shard this table based on the court. So here we're using court as what we call the shard key. And the shard key or shard keys are essentially the columns that you're going to use as the basis for sharding your table. So we're going to shard based on the court. So over here, we have this lookup table where we are assigning each court to a particular shard. And then the distribution of data will end up looking something like this for this example. So shard 1 has everyone from the summer court, shard 2 the spring court, shard 3 night court, and shard 4 the day court. Now this can be a great option if you have very specific criteria for sharding a table. It also makes it pretty simple to add new courts to this table. So maybe we have 4 new courts join. All we need to do then is spin up 4 new shards and throw each of those courts in the lookup table. We also have the option to assign multiple courts to one shard. So maybe the autumn court joins. We assign summer and autumn to shard 1. Maybe the winter court joins and we assign them to shard 2 with the spring court. Sorry, winter, nobody wants to be with the spring court. If you know, you know. Regardless, this method makes it simple to just throw new things into this lookup table. Now, there are also significant downsides to this method. As you might imagine, it's pretty simple to overload a single shard depending on what you're using as a shard key. So as you can see right here, the night court has way more members than all the other courts. So we ended up with a lot of people on shard 3. You also might have members that are way more active in doing whatever your application does. So those members could end up easily overloading a certain shard and creating a hotspot. In short, distribution can really become a problem with this method. And not to mention, we have the lookup table itself. This just adds an extra step in that journey to go retrieve data. In practice, you'd want to heavily cache this lookup table, but regardless, it's still going to add that extra step there. All right, so next up, we have range-based sharding. With range-based sharding, you're splitting things up based on a range and then mapping each range to a certain shard. So let's say, for example, you, for some reason, wanted to shard based on name here. So in that case, what we would do is split up the ranges. We're gonna take the first letter of each name and assign a shard to whatever range we choose. So maybe we choose A through G goes to shard 1, H through N to shard 2, and so on. The data will end up looking something like this. Now, the problem with this setup might be immediately clear to you. Depending on the ranges you choose and the shard key you choose, you could easily end up overloading shards again. So, as you can see here, shard 1, we ended up with 5 members, and shard 4 has 0. This is, of course, because certain letters occur much more frequently as the first letter in a name. So this is a silly example, but I really just wanted to drive the point home that depending on the range you choose, you could end up with problems. Hi, it's me from the future, realizing that my diagrams kind of suck. So you might be wondering, why do both of these examples seem to have a lookup table here? So we're showing this ranges table that is mapping the ranges to the shard. There's 4 shards, 4 sets of ranges. In the lookup example, we had kind of the same thing. And in that scenario, one of the downsides was the lookup table itself. So why is that not a downside in this range-based scenario? Because it's actually not a factor. My example here is just a little confusing. So for simplicity, I'm only showing a few records in this table. In reality, if you're sharding a table, you're going to have millions and millions of records in it. And at that point, if you are having to use a lookup table, it's because you have hundreds, maybe even thousands or hundreds of thousands of mappings. So in that previous example, we only had 4 courts there. At that point, you could just throw that logic into your app. You wouldn't need to rely on a separate table. But when you have thousands, you might need to start throwing that into a lookup table. In this range-based method, we have a finite number of ranges here, and typically it's going to be fairly small. So with this method, you can just keep that logic in the app instead of moving it into a different table. You'll see the same thing with the hash-based example we're going to do next. Another finite number of ranges there. So these diagrams are just meant to show what the mappings would look like. You're not actually creating a separate table for these 2 methods here. And if you did create a separate table, then it becomes lookup-based sharding. Hopefully that clarifies if this was confusing. Bye. Now, there are definitely ways to avoid this. So maybe we notice here that shard 1 is growing very quickly and shard 4 isn't growing at all. So instead, we come down here, we redistribute those ranges. Maybe we even add a 5th shard just to better distribute things. So here we reduce the number of letters that can end up in this first range, and then we expanded the range of shard 5. So as you can see, this ended up with a much more even distribution, which is what we want. Overall, this is a relatively simple approach to sharding and can be a great choice. All right, the final type of sharding that we're going to discuss is hash-based sharding. So with hash-based sharding, you're going to take your shard key, you'll take that value and pass it through a hash function. You'll then take the output of that hash function and shard based on that. So in a way, this is similar to range-based sharding that we just talked about, but instead of sharding based on, say, name, like in the last example, this time we're going to shard based on an alphanumeric value that comes out of the hash function. So for example, we have that members table here again. We're going to take the ID and use it as the shard key. So we'll run this ID of 100 through the hash function. We'll get some output, and then that output will be mapped to a specific shard. So in this case, our hash function outputs values that start with anything from 0 through F. So we'll take that and map each of those ranges to a shard. As you can see here, each member has its own hash here, and we'll shard based on that. This is the result we get using those ranges. Now, some of the pros of this method are you're sort of taking the human logic out of distribution here. There's less chance of overloading a shard because you're doing it sort of pseudo-randomly. And if you look back at all of our examples, this method did give us the most even distribution right off the bat. Now, that doesn't mean you should just arbitrarily shard your database based on anything. You can and should still choose a meaningful shard key here. All right, now that we have covered some of the more conceptual parts of sharding, I want to bring in my friend Jonah from our solutions engineering team here at PlanetScale. I sat down with him and asked him some questions about what his experiences are with sharding in practice. He has spent literally decades doing this for very large companies, so we had a really interesting conversation. If you have any questions for Jonah, feel free to leave those below as well. He's more than happy to come back on the channel and do an open Q&A with you all if you'd like that. So leave those questions below and let's get into it. Welcome to the PlanetScale YouTube channel. Can you please introduce yourself?
Yeah, my name is Jonah Berquist. I do databases. I think is what we said. My name's Jonah Berquist. I'm a solutions architect here at PlanetScale. My background is in running databases. I before coming to PlanetScale, I built and led the database infrastructure team at GitHub. Before that, did database reliability engineering at Twitter. Since those things, I've been working with a lot of our large customers moving over to PlanetScale, evaluating and also just migrating their data sets over.
Perfect. Well, you seem very well qualified to teach us about sharding.
I know a thing or two.
So, Jonah, I started this video by asking the audience what they would do if somebody threw a database in front of them and said, shard this thing. Now, I am going to ask you the exact same question. So, just in general, what would your approach be if somebody presents you with a database and says, we need to shard this? Where would you start?
Depending on what the workload looks like, there's going to be a lot of different ways that you do it, and there are going to be some tables that might be very obvious and others that might not be very obvious. Looking at the schema can help, but also understanding the workload so that you kind of know logically how does the data fit together, and what pieces of the data are joined together often.
Okay, so it sounds like just throwing a database at you isn't going to cut it. You need to learn more about the queries, what you're trying to solve for, and just some additional stuff before you can just go in and start sharding.
I mean, the real thing is like any large production environment. The real answer is it depends.
Right. Love it. So, Jonah, so far in this video, we've kind of discussed some of the different types of sharding you can do. So, we've covered lookup-based sharding, range-based sharding, and hash-based sharding. There seem to be some pros and cons with each of the different approaches. In your experience, is there sort of a default, or do you have any opinions on how you would choose which type of sharding you go with?
Yeah, I think there are some defaults depending on what we're talking about. Often you'll see when folks are kind of having a homegrown sharded system, something that they've built themselves. We used to see this a lot back in the day before there were things like Vitesse. When you really had to build your own, roll your own sharding, there was a lot of range based sharding, and that was easy to implement, but less flexible than some of the things that we can do now. Especially because the ranges were often kind of static. Lookup-based sharding is another one that we've seen a lot of, but like again, there are some pros and cons, right? The major disadvantage is that like you're doing an extra lookup for everything, right? In order to figure out where does this row live, you need to go and consult whatever that directory is. And then there's hash-based sharding, which is there are different ways to approach it. The real question is like, what are you hashing, right? If you're hashing something that's meaningful, you're really getting kind of the best of all these worlds. So in Vitesse, when we talk about hash sharding, what we're talking about is taking some column or set of columns that are going to be essentially your primary sharding key, your primary index, we say, and then we hash that. Once we've hashed our primary sharding key, we essentially take ranges of that resulting hash, and those end up being the shards that we live on. So depending on how many shards we have in a system, if we have 4 or 8 or 16, it'll be portions of of a hex range that define what what those original sharding keys that then get hashed into something, where they live on the resulting like end data store.
That makes sense. So in a way, is hash-based sharding in Vitesse almost a combination of range-based and hash?
Yeah, so everything that is using the hash, it's really using a range on the hash. So um, it's a little different in that, like, if we're thinking about, let's say you have some database with customers in it, right? And you have a customer ID, and that might be a big int. We're not talking about having 0 through 10 million on one shard, 10 million and one through 20 million on the next. What we're talking about is something that's going to distribute it a little more evenly, because we're going to first hash each of those numbers, and then that will distribute it, and then that hash will result in the shard placement.
That makes sense. Versus range-based, it's maybe kind of easy to overload a shard.
Yeah, especially if you think about if you're doing it just kind of in something that is a range that is going to increase over time. Your newest thing might be, your newest shard might be your busiest shard all the time. Alternatively, that you might have like real hot spots in certain places, and having some hashing can help to spread it out.
Okay. So if hashing is typically a good default, what type of scenarios are there in your experience where you do go for a lookup table?
Yeah, lookup tables can be useful, mainly if you have some very specific use cases where you want to place things in certain areas. So one of the like classic examples of a lookup-based sharding would be geo-sharding, or the idea being that you have a list of locations, countries, maybe regions, and you've mapped those to certain shards, so that you can say, hey, this shard lives over here, this shard lives over here, and then the data that's associated with it lives in each of those spots. It's often not the best idea to just kind of like put that on the database's plate, though.
Do we have a hot take coming in, Jonah?
I mean, the hot take is that geo-sharding isn't really something that people do.
Okay.
There are some out there, but more often than not, you want to have it done both at the application layer and at the database layer, rather than just at the database layer. So if you're talking about keeping things geographically separated, probably you want your whole app stack to be geographically separated. And at that point, just having a lookup index to have it applied at the database layer, it doesn't make sense anymore.
Right. All right. So geo-based sharding is not it. Are there any other scenarios where you might actually use a lookup table for sharding?
It's a valuable option to have. So the way that I would think about this, and a place that I would often do it, is if maybe you are moving from a legacy system and trying to get into sharding, it can be helpful to take, maybe you've already kind of broken things up in a specific way at the application layer, and you want to then transition that into a better managed sharding system like Vitesse. Using a lookup table to kind of map to how you've been doing it can be a real valuable way to help ease that transition.
That makes a lot of sense. Okay. But if you're starting fresh, maybe go with hash base most of
I
the
love a hash.
time. Good. Okay.
Figure out what your sharding key should be, and then hash on that most of the time.
Excellent. All right. So I want to throw a scenario at you. I have this massive database. We're getting in the terabyte range. It's growing really fast. Writes are coming in. They're getting heavy and hot. Ooh, that's weird.
It's getting hot and heavy. This database is hot and heavy.
I think we're ready to shard. I just don't know where to begin. So, for the schema, our main two problematic tables are our users table and then our messages table. This app is, we call it Tweeter. You probably are not familiar with this space at all. I know you worked at Twitter, but
It's a microblogging website.
yeah, something like that. It's very different, proprietary stuff. So we got these two tables. Messages table is, of course, much larger than the users table. It has user ID on it. Users table got its own ID. What would your approach be to start to shard this thing? Like I said, we're getting in the terabyte range. Things are starting to slow down. What should we do here?
So the messages table is really big, right? If we think about this in the simplest way, where maybe you don't have all of the social graph, maybe you don't have all of the timeline graphs to push things out to your followers, but you have like users and they send messages, and it's just like a status update. And if you want to see the messages from a user, you go to that user's page, right? In something like that, it makes a lot of sense to have, again, depending on how this works and what the traffic patterns are. But one way to think about this would be if we're often joining a user to that user's messages, putting those things on the same shard. So sharding both of those by user ID could make sense. There's another way to think about it, though, where it might not make sense. So, for example, let's say you've got certain users who are just posting a lot of messages. They're overwhelming the system. It's not that you have a even distribution, but you've got like just a handful that are spamming really hard, and you want to let them do that. It might make more sense to break these two things apart. Kind of do a bit of vertical sharding first. So sometimes we talk about this as like functional partitioning, but the concept behind vertical sharding is to say, this table, we're going to put it over here in this key space. This table, we're going to put over here in this other key space. Before we even start to talk about scaling any individual table horizontally. But then we can also start to say, like, okay, let's take a look at this messages table just by itself. How would we want to break that up? Maybe by user ID, maybe by some sort of message ID. It might make sense to just say, like, hey, these messages, we don't necessarily need to ever get a group of them from the same user. So it doesn't matter if they're on different hosts. Now, obviously, that's not the architecture that I just described us having for this application. But the way to think about this is it all depends on what the application is doing and how the application is accessing that data and displaying that data and what those patterns look like. Because the more you understand those access patterns, the better your sharding framework can reflect it and give you really high performance sharding.
So the main thing you're trying to consider here is when one type of data is accessed, do you frequently access a different type of data or run a different query at the same time? Because you don't want to have to make several trips across different shards in one transaction to bring them all together, or
having data that gets accessed together a lot, especially if there are aggregates or things, having that stuff live on on the same shard is helpful because it lets the system push down some of that work to the underlying storage, in our case, the underlying MySQL system, and just let it happen there rather than pulling it from disparate sources where it may need to then send more things across the network and then work in another layer to perform some of those aggregates. So it can be real useful to have stuff kind of in groups, right? Often, you want to have all of your things for one customer together or one user.
All right. So to summarize, for my Tweeter database that is in the terabytes range, it's slowing down, we're getting lots of writes. I think it is time to shard. So based on talking to you, I think I'm going to go with the hash-based method. We're going to shard on that user ID, and I'll keep an eye out for hotspots. We got Taylor Swift on the app, so she might need her own shard.
Yeah, it's good. One thing to keep in mind is you can customize what those ranges of those hashes are as well. So if you've got something that is a hotspot, changing it around a bit might help you break some of those things out.
All right, Jonah, thank you so much for joining us. I learned a ton. I feel like I'm ready to shard my database now.
Yeah, thanks for having me. It's been great.
If you have any additional questions for Jonah, feel free to leave them in the comments below. We can always record a part 2 and you can get all of your questions answered. Or if you do have a large database you think is in need of sharding, head to planetscale.com/contact. Tell us a little bit about your problem and me and Jonah will read them. All right, see you in the next one. Bye.